Hey there, welcome back. In today's video, we'll walk through setting up PostgreSQL Replication service. Replication is key for ensuring high availability and data redundancy in a production environment, especially when you're managing critical data. We'll cover how to set up replication between a primary server and a standby server. Let's dive in. Before we start, here's what you'll need. 2 servers. One is the primary server with IP 192.168.29.173, and the other as the standby server with IP 192.168.29.251. These IP values are used only for demonstrative purpose. Make sure PostgreSQL is installed on both servers. For this tutorial, we are using 2 Fedora 41 beta Linux servers. If you need help with configuring the firewall or setting up SSH tunneling, check out our installation videos using the links provided in the description box. In your case, adjust the IP addresses according to your needs. As we've already mentioned, the primary and standby servers do not need to be on the same IP segment. They can operate with any public IP addresses. Additionally, each server is protected by a firewall, and SSH tunneling is available as an optional feature. Let's start with the primary server setup. First, we need to configure some parameters in PostgreSQL. Modify the PostgreSQL configuration file. Add or update these lines. Now, configure the authentication file. Host replication replicator 01192.168.29.252/32 trust. create a replication user on the primary server. Create user replicator 01 replication login connection limit 10 encrypted password, your $election. Finally, configure the firewall for PostgreSQL to allow traffic from the standby server. Restart the PostgreSQL service on the primary server. Now, let's move to the standby server. We've opened another terminal on the right side for the standby server. From this point onward, the left terminal will be used for the primary server and the right terminal for the standby server. Please be careful, as we will switch between the two terminals frequently and may not always mention it. Also, note that we are connecting to the standby server via SSH. Check the firewall. On the standby server, PostgreSQL service does not need to be kept open externally. First, stop the PostgreSQL service if necessary and remove all existing data. Be careful. Using the rm command with the rf options is very dangerous. Double-check before executing. Clone the data from the primary server using the pg_base backup command. This command can be difficult to remember, so refer to the online manual or documentation for detailed instructions if needed. Restart PostgreSQL on the standby server. Wow! The replication service is up and running. Once everything is set up, let's verify that the replication is working properly. On the primary server, check the replication status. At this point, you should see active replication processes between the servers. Try running some basic SQL queries on the primary server and watch the changes appear on the standby. On the primary side, if your servers are connected over a public network or the internet, it's recommended to set up replication over SSH for secure data transfer. Here's a quick overview. The PostgreSQL service is blocked on the primary server. On the primary server, modify the pg_hba FONF file to restrict access to localhost. Adjust SELinux policies if necessary, especially for Fedora systems where SELinux is enabled. When trying to operate the replication service over an SSH tunnel, we cannot use PostgreSQL's standard port number, 5432, for tunneling on the standby server. Therefore, the SELinux policy needs to be updated for the new port number, 5434. This change is only required for the standby server, not the primary server. On the standby server, modify the PostgreSQL auto-onf file to include the SSH tunnel configuration. Now, the replication service connects to the local port 5434, which, in turn, connects to the primary server over the SSH tunnel. Create the SSH tunnel from the standby server. Configuration of both servers is complete. Finally, we are restarting both servers. And that's it. You've successfully set up PostgreSQL replication. Whether it's for high availability or data redundancy, this setup ensures your data stays safe and synchronized. If you found this video helpful, give it a thumbs up and subscribe for more tutorials. Thanks for watching, and happy coding!